Welcome to AP Stats. This is Tuesday, November 19th of the year 2019. We're going to take a look at the homework that's due today. It was assignment 1 in Unit 5. And the first 4 parts of problem 1, I'm going to give you feedback on that before you, if you're watching by video, you haven't turned this in yet. So please do not change your answers, even though I'm going to give you the answers to parts A, B, C, and D. However, parts E, F, and G, you needed more discussion on those before turning them in. So you are permitted to change your answers to parts E, F, and G based on the discussion that you see here on this video. So you're just on the honor system to not change parts A, B, C, and D. So this is the homework. Just give it to me as soon as you get back from your absence. In this problem about Twin Groves Junior High, the subject studied, what you should have written there are the 12 volunteer students from Twin Groves Junior High. The factors in the experiment, you should have those listed out as separately as 2 factors with the levels for each. For example, you should have indicated that there's the size factor. So in sentence form, you would say one factor was size. It had 2 levels, 15-inch and 17-inch. And the second factor was speed. And there were 3 levels of speed, 20 words per minute, 40 words per minute, and 80 words per minute. So that's the content that should have been in part B. By the way, this problem is reminiscent of the physician's aspirin study, where they were looking at what proportion of the subjects had heart attacks. And there we altered it a little bit, sunlight, yes or no, which was not in the original study. But here we have the size factor. Factor 1, we'll call it F1, is size. There were 2 levels, 15-inch and 17-inch. And the second factor, we'll call it factor 2, was speed. And there were 3 levels of speed, 20 words per minute, 40 words per minute, and 80 words per minute. The units do matter. Now for the treatments, now that I've set up my factors in a 2-way table, which makes you wonder what would happen if there were 3 or more factors, how would you fit that into a table? But they usually don't do that. So anyway, 2 factors. I mean, you could do it, but right now we've got 6 cells in the table, so I can tell that there's going to be 6 treatments. Treatments 1, 2, 3, treatments 4, 5, and 6. So when it comes to part C, when you listed the treatments, you can't just leave it as a table. You actually have to write out the list of all 6 treatments. I don't care which order you go in, but it would go something like this. Your treatment list might have been for part C. Treatment 1 was the 15-inch monitor, 20 words per minute. It's first item in the list. And then 15-inch, 40 words per minute. 15-inch, 80 words per minute. Then treatment 4 might have been 17-inch, 20 words per minute, all the way down to treatment 6, which would be 17-inch, 80 words per minute. So that's how you should have listed the treatments in part C. Part D, the response variable measured. Now the response variable, ask yourself, does the response variable have to be always a categorical variable or always a quantitative variable? I want to pause the camera before I give the answer. Okay, the answer is that the response variable must always be a quantitative variable. In fact, the quantity tends to be a parameter, either a mean of something or a proportion of something. So in this case, they are comparing the mean. Oh, it's a mean. The mean reading comprehension score. So for a response variable, you should have had written on your homework, the mean reading comprehension score. You don't have to say for each group, but that'd be fun if you did. Now, parts E, F, and G. If you want to change your answers to parts E, F, and G based on what I'm about to share, that's fine. You can do that and still maintain your academic integrity. So is the design completely randomized, match pairs, version of blocked? Which one is it? Well, in order to answer questions about what type of design, it's best to attempt to draw a diagram of the design. So here's how you would diagram draw a diagram of the experiment. So here's how you would diagram it. We had 12 volunteers at the high school and the junior high school, Twin Groves Junior High. Be pretty close to Stevens High School. There were 6 treatments. We listed them in Part C. Treatment 1 was a 15-inch monitor at 20 words per minute. Treatment 2, and your diagram should have the word, it's treatment 6, should have the word randomize. So write the word, you see the yellow here, I'm going to change it to green, easier to see. Write the word randomize the assignments here. So, now that we see what's going on, it's not the sort of thing where they blocked the experiment, where they took 6 guys and 6 gals, G-U-Y-S, 6 boys and 6 girls, and they have a guy block and a gal block, and they take the 6 guys and randomly assign them to 6 treatments, treatment 1 through treatment 6, and take the 6 gals and randomly assign them to 3, 4, 5, 6 treatments, treatment 1 through treatment 6. No, that would be a blocked design where we're blocking by gender. It was not blocked, by the way, that phrase in there, matched pairs. Matched pairs, just make a note to yourself, matched pairs design is blocks of size 2. We'll find out why it's so common to do matched pairs, which are blocks of size 2. It's not blocks of size 6, so it's not blocks of size 2, so it's not matched pairs, it's just completely randomized. So the answer to this one is it's completely randomized because all of the volunteers started together in one block. Whenever the number of blocks is 2 or more, then we say it's blocked. But if there's only one block of volunteers at the beginning, then it's not blocked, it's completely randomized. So that's how you can figure out what the design is. And by the way, blocking variables tend to be, if you do block, you usually block by something that cannot be assigned. You can assign someone a 12-inch screen or a 15-inch screen. You cannot assign them their gender. So, but you can block by gender. Well, we can't tell you to be a guy, but we can say, if you are a guy, then you be over here, and then we're going to analyze and draw a conclusion separately for the guys and maybe a different conclusion for the girls. So we can block by gender because we cannot assign someone their gender. We can block by age because we can't assign an age. Ethnicity because by health status, because you can't say, oh, you're going to be sick, or you're going to be someone who's taken estrogen for the past 6 months. No. So you can block by health, and you can health or medical status. So these are common blocking variables, but we didn't do that here. So that's why the answer was completely randomized. Let's go on to part F. Is the design blind, double blind, or neither? You can also see that in the diagram and in the verbiage. Look, we are, for treatment group 1, we are calculating the value of the response variable, which is for these 2 people, you can tell there's 2 people in each treatment group because there's 12 volunteers and 6 treatments. So number of people per treatment group is 12 divided by 6 is 2. So we take, of these 2 people who underwent treatment 1, we get their mean reading comprehension score for group 1, the mean reading comprehension score for group 2, all the way down to mean, which is really X bar, for group 6. Okay, and then we compare these. If any one of these is statistically significantly higher than the rest, then we can report that. But the reason we would blind is because scientists are human, and humans sometimes cheat. What if you're a scientist who works for a company that sells treatment 6, the big monitors, where they have a big profit margin, and the super fast software that's really expensive. So if it were blinded, then the reason to blind it is that there might be researchers who are saying, well, yeah, you've been randomly selected for treatment 6 using rand integer 1, 12, 2. We're going to randomly pick 2 numbers, or maybe just put 12 numbers in a hat. We assign the integers 1 to 12 to each of the 12 volunteers. And we take 2 numbers out of a hat and say, okay, persons numbers 3 and 8, you have been randomly selected for treatment. But if I'm not blind and I actually see these people and they look like, oh, the way they're dressed, I think they're probably really good at reading comprehension, so I'm going to give them treatment 6 because that's the treatment with the expensive equipment. So we want to be able to report out that if you buy the big monitor with the super fast software, then your kids will be great at reading and they'll end up being able to go to the college of their choice. And that's corruption. That's it's a biased response. We don't want that. So blinding can prevent human scientists from cheating by saying, okay, I'm not looking, whoever you are, persons 3 and 8, if you've been randomly assigned 3 or 8, go over to station number 1. But they didn't have that kind of description. They didn't attempt to blind the process of assigning volunteers to treatments. So if they did, that would have been at least single blinding. And then if they had blinded the calculation of the response variable, if it's blind, then the person who calculates the response variables say, oh, let's see how good your reading comprehension score is. You got 98%, way to go. That person who writes down the 98% in the book should have no knowledge of what treatment they received. Otherwise, they might cheat. They might say, oh, you were treated with the big screen and the fast software. So I don't care if your reading comprehension score was a 53%. I'm going to give you a 98% because I want to make the expensive software looks like it really helps people, the expensive hardware. So there should be blindness as to which treatment was received when you record the response variable. That's blindness on the back end, but there should also be blindness on the front end. We don't see any of that. And so that's why we can say that the answer to part F is the design is neither single blind nor double blind. It's neither blind nor double blind. Why? And just put it into your own words. We didn't go out of our way to make sure that the researchers were unaware of which randomly selected students were assigned to the treatments, and we did not go out of our way to make sure that the measurement of the response variable, in this case the mean reading comprehension score, that the person who wrote those down was unaware of which treatment they received. So it was neither. If someone were to replicate this experiment, they would follow these directions, and there's nothing there that blinds it. Now, part G, what is the nature? When you're answering the question about the nature of a conclusion, it depends on the type of study that it is. If your type of study is an observational study, let's get dark blue here, it's a little easier to see. If your study is observational, then your conclusion can address whether or not there's an association. That's the nature of it. It's a statement about association. Oh, there is an association or a link. There's not an association. You can't talk about cause and effect. That cannot be the nature of your conclusion. If it's an observational experiment, then your conclusion can address the question of association, not cause and effect. However, then if your study is an experiment, then your conclusion by nature will address the question of cause and effect. So those are the two options for nature. Which is it in this case? If you want to think about it, pause and then restart, and I'll tell you. All right, welcome back. Because this is an experiment, how do we know an experiment? Treatments are imposed. There were 6 treatments imposed. People had no choice. They were just told, you volunteered, okay, we're going to impose a treatment on you. And so because it was an experiment, because treatments weren't imposed, the nature of the conclusion will be a discussion of the question of cause and effect. Now, how about the scope? The scope is, to whom does this conclusion apply? And do these results apply to elephants or male squid? Or does it apply to all women on the East Coast of the United States or all high school students? I mean, you don't want to say it only applies to the 12 volunteers, because the whole point of doing this study is so that we can make a statement about this software and the hardware and the treatment that a lot of people would be interested in perhaps purchasing. So it would be, yeah, I mean, if you're going to be really super conservative, you can say, well, this applies to all students at Twin Groves Junior High. Well, maybe Twin Groves Junior High is representative of a lot of other places. So maybe you could say, you know, can you say all junior high students who have, well, you don't have to say the same reading score, because that was just to reduce noise, to keep variability in the response variable low. But you could probably say for all junior high students, or you might even be able to say for all junior or senior high school students. It might be reasonable, but the point is, if you're going to publish that and put your name on it, and say that's the scope, then your reputation is at stake, because people might read your conclusion and say, whoa, can you believe what so-and-so said, that they think that this study applies to all of those people in that group? So just watch your scope, make sure it's not too broad, not too narrow. And so hand this homework to me when you come in. We'll actually do number 2 on block day. You don't have to do this homework. Now, the next thing I asked you to do for homework was, okay, we're gonna pause here for a second. Writing back. Now we're going to take a look at the practice quiz. Now, just so you know, I've decided that on Thursday, instead of giving you a quiz in class, I'm going to give you the quiz as a take-home. You're on the honor system to not collaborate with other people. It is open note, but closed internet, closed other people. If you want, you can pray. God is a person. But other than prayer, you're not allowed access to any other people when you're doing the take-home quiz. The take-home quiz is online. All you do is go to AP Stats either period 4 or period 5 or period 6 and go to unit 5. And in unit 5, you're going to see the take-home quiz, which is due on November 21st. Unless for some reason you're absent, it's due the first day you get back. So do the take-home quiz at home, open note, closed other person, and it's due on Thursday or your first day back. Let's look at the practice quiz. And the practice quiz was the menopause problem. What specific type of experiment was this? It was just, it was actually blocked, because if you were to diagram this experiment, you would see that if you read carefully, there were 12 women, 12 volunteers who had been taking estrogen, so on estrogen, and they were randomly assigned. So here's a diagram of the experiment. They were randomly assigned to either the alcohol treatment or the no alcohol beverage, alcoholic beverage or no alcoholic beverage. And then, since you can't assign someone to, okay, we're going to give you the treatment of having been on estrogen for the past 12 months. No, we can't assign your medical status. So we took 12 volunteers who were not on estrogen. So this is blocking. Now, keep in mind that blocking in experiments is the same thing as stratification, or it's comparable to stratification in surveys. You would take the population, in surveys, you take the population, you can break it up into strata, and then survey each stratum. Now, in experiments, we don't call them strata, we call them blocks. So you can take your volunteers and break them up into 2 blocks. These are blocks of size 12. And then you can randomly assign them to treatments. The reason we're doing this is because we think that there might be a lot of variability in estrogen between people who are already on estrogen and those who are not. So we don't want that noise to get in the way of reading the signal. Don't ever say noise on the AP test. Talk about, instead of noise, use the phrase variability in the response variable due to factors that are not under study. Instead of signal, use the word variability in the response variable due to factors that are under study. So anyway, alcohol, no alcohol. So that's what's going on in this. We measure their estrogen level, compare it, but back to this, the question is, it's randomized block. We're blocking by estrogen use. I didn't mean to press that. Okay, so we're blocking by estrogen use, and it's part A. In part B, what are the factors? There's only one factor. It has two levels. There's the beverage factor. And the level 1 of beverage is alcoholic drink. Level 2 is non-alcoholic drink. The response variable is, see what they're measuring, 1 hour later, everyone's estrogen level is checked. Only those supplemental that showed a marked increase. Okay, so your response variable ideally is going to be either, it should be a parameter, either mean or proportion. And you could have said, the proportion of women who have increased estrogen. But here they picked mean. These are the grading messages to the person who's grading this. Whatever you select, it has to be a quantitative variable. It can't be categorical, but you only get partial credit unless you say, what change are we looking at? Yep. We're looking for those who showed a marked increase. Only those on supplemental estrogen who drank alcohol showed a marked increase. How do we know it's an increase? Because we subtracted the final amount minus the initial amount. So it's like after alcoholic beverage, or after beverage minus before beverage. And that applied only to those who had been in that first block, who were on supplemental estrogen. So anyway, to get an E here, you would have had to say either mean or proportion, mean change in the estrogen level, and specify that we're calculating the change by taking the after amount minus the before amount. The treatments are the same as the levels. Because there's only one factor, whatever the levels are going to be the treatments. It's treatment 1, you didn't say the list them, just state them. But if it said list them, you would have done treatment 1 is drink alcoholic beverage. Treatment 2 is drink non-alcoholic beverage. Let's go to the next page. In page 2, okay, explain why this is an experiment. Because treatments were imposed. Don't say anything more. I mean, if you wanted to say more, there's other ways to get credit. Subjects were randomly assigned to 2 treatment groups. Okay, that's great, that's wonderful, but you're using more words than you have to. Part B, the results of the experiment showed that the difference to be statistically significant. What does that mean? It means that the difference in mean reduction in prostate size, and I think there's a typo here, in prostate size was larger than what can reasonably be attributed to, you can say the chance, or you can say natural sampling variation. That's just your script for the phrase statistically significant, nothing fancy there, just applied to this context. Part C said, okay, suppose after the experiment, the researchers found that men who had the new treatment had a mean reduction in prostate size, 40 grams more than for the men who had the standard treatment. And assume that the difference in reduction in prostate size between the 2 groups follows a normal model with a mean of 0 grams, standard deviation of 17. Determine the probability that we could find a mean reduction between the 2 groups using the new minus standard direction of subtraction to be 40 grams or more. Show your calculations. Friends, this is where we do model, mechanics, conclusion. We're tying together this lesson, this unit to previous units. So here's where we say, okay, look, we have a distribution of differences in mean reduction between the 2 groups. And we're assuming that there's going to be no reduction, that this new treatment makes no difference whatsoever. So we're going to assume there's no difference, but guess what? We observed a difference of 40 grams. Okay, so look at the normal model. We're assuming 0, and whoops, that's a mistake. They said the standard deviation was 17. We observed 40, but they said mean 0, standard deviation is 17. We observed 40. They say, what's the probability that you observe a mean difference of 40 grams or more? And so that's a data value X, that's what we observed an X value. How many standard deviations is that above the mean? So model is normal model 0.17, the mechanics is, let's see, how many standard deviations is 40 above the mean? Let's look at the deviation. Let's take X minus mean as the deviation, then to find out how many standard deviations divided by sigma. So it's gonna be 40 minus 0 divided by 17. And according to my calculator, 40 minus 0 divided by 17 comes out to be about 2.353 standard deviations, 2.353. So we bring that over, 2.353. And when you do normal CDF, to find out what the area, you need 4 numbers in here, 1, 2, 3, the fourth one is the probability normal CDF of 2.353, comma, infinity is 999, you get about 0.009. And that's the answer. They didn't call for an interpretation, but now that you know the eyeball statement concept and the brain statement concept, you actually can take this further. If someone asked you to explain, okay, what is meant by this probability of 0.009? You can actually interpret that, and I've got my wireless keyboard so I can just sit here and type in the answer, even though it's not called for in this problem. Let's connect the meaning of 0.009 to what we've been learning in the past. So you can say the probability of 0.009 means that, I don't like the way I worded that. I'm going to say 0.009 is the probability that we observe, here's the eyeball statement, that we observe a mean difference of 40 grams or more in prostate size reduction due to chance alone, given, and now for the brain statement, the belief is that the null hypothesis, there is actually no so there is, I'm going to say, given the mean difference in prostate size is actually 0. So if it's really 0, if the mean difference is really 0, what's the probability that we observe in our volunteers a difference of 40 grams or more, just due to chance? And so that's a connection of what this probability means. But they didn't ask for that, so you can relax. You don't have to do that on Thursday's test. But we will have to second semester, so this is good practice for what's coming up. Finally, on the quiz, the practice quiz we had, if you wanted to block the experiment, on what variable might you block? So again, we could block on age or on health status. In particular, some health status regarding, that's related to this problem. So something about maybe, or maybe how long you've been struggling with prostate symptoms. Why should you block? So you would have to explain that. It could be differences based on age, race, ethnic background, severity of problem, etc. So that is the practice quiz. So that's all we need to look at. The take-home quiz is due on Thursday. Have a good night. You are dismissed.